Hello students, today I would like to discuss an important topic for IIT entrance exam, absolute value or modulus. Absolute value or modulus. So this is an important topic for IIT entrance exam. Every year you can find one or two questions from this topic. So let's first define absolute value. So let x be a real number. So the absolute value or modulus of a real number or of x is denoted by mod x and defined as mod x equals to minus x whenever x is less than 0. It is x whenever x is greater than equals to 0. So if x is negative, mod x is minus x. If x is positive, greater than equals to 0, mod x is x. So for example, mod of 2 is 2. Why? Because 2 is greater than 0. So it will fall in this case. And mod of minus 2 is minus of minus 2, which is 2. So why it is minus of minus 2? Because minus 2 is less than 0. So that means mod x is always positive. So we can write it as a remark. So mod x is always greater than equals to 0 for every x belongs to R, or for every real number. Or there can be one more important remark. Mod of x square is same as mod of x square. So it is sometimes important to write down this x square as a mod of x square, and mod of x square is mod of x square, and it is same as x square for every, it is true for every x belongs to R. So here R is set of real numbers. There are other remarks also, but I will write only these two remarks. And the graph of y equals to mod x, be y equals to, so first let's define this mod x. So y equals to mod x, it is minus x, y equals to minus x if x is less than 0, and y equals to x if x is greater than equals to 0. So to draw the graph of y equals to mod x, first draw these two lines, y equal to minus x and y equals to x. Okay, so let's draw these two lines. Y equal to x and y equals to minus x. This is y equal to minus x. So y equal to minus x for x less than 0. So we will take, so this line is y equal to minus x. So we will take only those values of y equal to minus x in which x is less than 0. So x is less than 0 this side. So we will take this portion only. We will take the graph of this portion only. Similarly, y equal to x, for x greater than equals to 0, so we will take this portion only. Okay, so the graph of y equal to mod x is this this V-shaped graph, this shaded portion, or this is y equal to mod x graph. Okay, so we have a sharp point at x equals to 0. Okay. So I would like to discuss question which is from IIT Advanced. IIT Advanced 2021. So the question is, for x belongs to R, the number of, or what are the number of real roots? The number of real roots, of the equation, the number of real roots of the equation 3x square minus 4 mod of x square minus 1 and plus mod of x minus 1 equals to 0. So the question was, how many solution of this, or how many roots of real roots of this equation. Okay, so in this equation you see we have a mod of x square minus 1. So first we will break this mod. Okay, so we have two conditions. So basically mod of x square minus 1, so we will break this mod like I have defined mod of x. So it is minus of x square minus 1 if x square minus 1 is less than 0, and it is x square minus 1 if x square minus 1 is greater than equals to 0. So that means we have two inequalities, x square minus 1 less than 0 and x square minus 1 greater than equals to 0. So first I will try to solve this inequality, x square minus 1 less than 0. So x square minus 1 less than 0. So there are lots of techniques to solve this inequality, x square minus 1 is less than 0. So there is a very famous technique solved using number line. So minus 1 and 1. So if you see, if you have idea of this, I assume you have idea of number line. So this portion will be positive, this is negative, and this is positive. So we are interested in this negative portion. That means x in between minus 1 and 1. So x square minus 1 less than 0. This implies x in between minus 1 and 1. And similarly for x square minus 1 greater than equals to 0. So we are interested only those values of x in which x square minus 1 is positive here and here. So that means x is less than minus 1 or x is greater than 1. So x is less than minus 1. So for x is less than equals to minus 1, or x is greater than equals to 1. I'm taking equalities because here also we have equalities. X is equality, x square minus 1 greater than equals to 0. So x is less than equals to minus 1 or x is greater than equals to 1. In some sense we can write it mod x is less than 1 and this is mod x is greater than equals to 1. So basically we will try to solve this equation under these two conditions. So for mod x is greater than equals to 1. So for mod x is greater than equals to 1, that means x square minus 1 is greater than equals to 0. And if x square minus 1 is greater than equals to 0, then this 3x square minus 4. So we will solve the equation under this condition. So 3x square minus 4 mod x square minus 1 plus x minus 1 equals to 0. This implies 3x square minus 4, because x square minus 1 is positive, then it will become x square mod x square minus 1 is just x square minus 1 plus x minus 1 equals to 0. And this implies 3 minus 4, so minus x square and minus 4, so minus 4 and plus x, and this minus 4 and minus 1, so minus 4 minus minus plus, so 4 minus 1 is 3, so plus 3 equals to 0. And this implies x square minus x minus 3 equals to 0. So now we have a quadratic equation. So the roots of this quadratic equation would be x equals to minus 1 b, so 1 plus minus b square minus 4ac, so 1 minus minus plus, so 4 3 is 12, so plus 12 upon 2. So basically one root is 1 plus square root 13 upon 2, and another root is 1 minus square root 13 upon 2. So now we will check these roots are under this condition, because this is the main condition. Under x greater than equals to 1, we are solving this quadratic equation. So if you take square root 13, so square root 13 is basically less than 4 or greater than 3. So if you take 3, so 3 plus 1 2, that means it is greater than 1. So okay, fine. And if you take this side, so it is less than this square root 13. Square root 13 is greater than 3, so 1 minus 3. So again it is minus 1, or so it is less than minus 1. 1 minus square root 13, if you see this quantity, so it is less than minus 1. So that means both roots will satisfy this mod x greater than equals to 1. Okay, so please try to see, means these two roots are satisfying mod x greater than equals to 1 or not. So that means these two are solution of our main equation. So next is if mod x is less than 1. If mod x is less than 1, then 3x square minus 4 mod x square minus 1 plus x minus 1 equals to 0. So this implies, so in this case x square minus 1 is negative. So in this case 3x square, so this mod x square minus 1 will become minus of x square minus 1 by the definition of modulus. So it is plus 4 minus minus plus, so 4 x square minus 1 plus x minus 1 equals to 0. And this implies 3x square plus 4x square minus 4 plus x minus 1 equals to 0. So 3 plus 4 7x square plus x minus minus 4 minus 1 is minus 5 equals to 0. And this implies x equals to, so the roots of this equation are x equals to minus 1, so minus 1 plus minus b square 1 minus 4ac, so 4 5 are 20, 7 are 140, and minus minus plus, so 140 upon 2 2a, so 2 7 are 14. So then again I'm getting two distinct real roots. One is -1 plus 141 upon 14, and another is -1 minus square root 141 upon 14. Okay, so again we have to check these two roots are satisfying mod x less than 1 or not. So to check mod x less than 1, so this is square root 141, it is less than 12. So basically 12 minus 1. So 12 minus 1 is 11. 11 upon 14, that means it is less than 1. And similarly it is 12. So if we see 12, so minus 1 and minus 12, so minus 13 upon 12, so it is greater than -1. Okay, so both the roots are satisfying this mod x less than 1. That means they are also solution. So total number of solutions are 4. Total number of solutions are, real solutions are 4. Total number of real solutions are 4. Okay, so I will stop here. Thank you.